Hello, good morning. Today I would like to explain about pyrometers. So pyrometer is a device that is used for measurement of an object. So pyrometer is one of the temperature measurement transducer. This will measure the temperatures between the range of 700 degrees to 2500 degrees centigrade. So whenever if you are measuring higher temperatures, so this pyrometer is more useful. So measuring molten metals, this is used for measuring furnace temperatures, measuring liquid casting and liquid alloys of temperatures. So normally for measuring higher temperatures, pyrometers are normally we are using. So in the last class we discussed there are two types of pyrometers. One is radiation pyrometer, the second one is optical pyrometer. Okay, so in these radiation pyrometers to measure the temperatures in the range of 700 degrees to 2000 degrees centigrade, whereas optical pyrometers, it measures the temperatures from 700 degrees centigrade to 2500 degrees centigrade. Okay, so the pyrometer is a device. It is used for measurement of temperatures of an object. So the device actually tracks and measures the amount of heat that is radiated from an heat source or an object. The thermal heat radiation from the object to the optical system presents inside the pyrometer. Okay, so special arrangement we are using to measure the temperatures in terms of brightness. The optical system makes the thermal radiation into the better focus and passes to a detector. Okay, so here, so there are let's see how the optical pyrometer normally the system, optical pyrometer system is looks like this. Okay, so this is the arrangement. So here, so this is the temperature source and this one is optical pyrometer system. So what are the main components in it is, one is the outside there is a temperature source or radiation source, the temperature whose temperature is to be measured. So in one arrangement you are placing a glass bulb with filament and lenses, and other side observer through eyepiece you observe the radiation brightness of a filament you are observing. So the main principle of operation of optical pyrometer is, if the brightness of radiation zone by seeing to measure the temperatures. By seeing the brightness of the radiation zone, the brightness of is more, the temperature is also more. The brightness of radiation zone is less, the temperature is less. Means we can find the temperature in terms of brightness. So measuring the brightness of radiation, it is an index of to measure the temperature of a radiation or heated zone. Okay, so these are the circuit arrangement of optical pyrometer. So let's see what are the importance of each and every component we will discuss now. Okay, so first all of you draw the circuit diagram and this circuit arrangement. So these are the main components of optical pyrometer. So as shown in figure above, the optical pyrometer has the following components. So at the left side of the diagram is the eyepiece at the left side and an optical lens on the right side. Okay, a reference lamp which is powered with the help of battery. So the filament is connected to the battery system. So here a rheostat is normally using rheostat to change the current, hence the brightness intensity is changing by adjusting the rheostat. So how much amount of temperature is focused on the radiation zone through this arrangement to measure the voltage directly. Okay, so to increase the temperature range which is to be measured at the observer screen is fitted between the optical lens and the reference bulb. So there are two filters One is observing filter, the other one is red filter. So the red filter observes the red light to the observer, and the observation filter is nothing but to observe the screen is fitted between the optical lens and reference bulb to observe the heat radiation from the heating source. So what is the working function of this optical pyrometer? Let's see. So the radiation from the source is emitted and the optical object lens is captured the radiation. Okay. The lens helps in focusing the thermal radiation on the reference bulb. Okay, the light radiation is falling onto the reference bulb. So the bulb intensity is increasing in two ways. One is to change the resistor or voltage across the circuit, and the radiation, thermal radiation, focus on through the screen. Okay, the observer watches the process through the eyepiece and correct it such a manner that the reference bulb filament has sharp focus and the filament is superimposed on the temperature source image. The observer starts changing the rheostat values and the current in the reference lamp changes. So this in turn change in its intensity. Okay, so this change in current can be observed in three ways. Normally in three ways we are observing the change in the filament. One is, so the filament is dark means, what is the meaning is the filament is dark means the cooler than the temperature source. Means the filament is dark means the temperature source is less, so the temperature is less, so that cooler than the temperature source. When the filament is dark, so it observes more temperature, so this cooler than the temperature source. When the filament is bright in case 2, it is hotter than the temperature source. When the filament appears bright from the eyepiece, so what we observed, the condition is hotter than the temperature source. Means more brightness you are observing, means the temperature is less. In the third case, filament is disappear, means there is equal brightness between the filament and temperature source. So the temperature source from the radiation zone is equal to the brightness of the filament by the time the filament is disappear from the observer. So in the three cases we observed from the optical pyrometer from the observer. Okay. By measuring the brightness, temperature directly you are measuring in terms of voltage. Okay. So in the three cases. So by the filament you are observing in three cases. One is cooler than the temperature. The filament is bright. In the second case is filament is dark, means it is cooler than the temperature source. Filament is bright means hotter than the temperature source. And the filament is disappear from the observer, it means the brightness between the filament and temperature source are equal. Okay, in three ways we are observing the filament. Okay, in terms of brightness to measure the temperatures directly. Okay, so what are the applications for this optical pyrometer is normally for measuring the temperatures more than 700 degrees centigrade. So to measuring the molten metals, it is used for measuring the liquid furnaces and liquid alloys, measuring the molten metals. So like that, for measuring any higher temperatures, so this pyrometer is more useful. The advantages, if you see, so it is no physical contact between the instrument and the measuring temperature source. That is one advantage. The accuracy is very high, that is plus or minus 5 degrees centigrade. So the main advantage is here is the instrument you are placing any distance. Okay, so it can the instrument can easily operate. So when the heat source is far from the system. Okay, so one biggest advantage of this device is that there is no direct contact between the pyrometer and the object whose temperature is is to be found out. So that is the reason the other name of optical pyrometer is contactless pyrometer also. Okay, so the disadvantage is normally what the limitations, if you see, the device is not useful for obtaining continuous values of temperatures at smaller intervals, so because of that, the temperature, if you are measuring continuous values, observer is required. So manually you are operating. Okay, so automatic arrangement is not at all possible. As the measurement is based on the light intensity, the device can be used only in application with minimum temperatures of 700 degrees Celsius. So if you are measuring the light intensity, so it requires minimum temperature range is 700 degrees centigrade. So below that the visibility is not appear clearly. So below that visibility is not appear. So this is the reason only above the 700 degrees temperatures only it measures. And continuously to measure, so in controlling process, so it's manually only you are observing. Okay, so automatic process is not at all involving. Okay, so these are the different advantages, limitations of optical pyrometer. Okay, so it is clear. Okay, thank you now.